All right. So, what I gather, the South African born Boykie, has got everything in the universe explained. I don't only partially understand most of what he's talking about, but that's what it sounds like to me. What do you think? Right, let's have a look here. All right, you can all switch on your microphones now and all talk at once if you like.
Yeah. Derek, can I just ask something? Could we watch it again? Are you going to send out a link?
Yes, I will. And I've also done a transcript of the whole thing, just without pictures. I haven't put any slides in yet, but I do have the transcript, so you can read through everything he says. It's sometimes a bit easier like that. So I'll send that to you as well, the document.
Okay, Derek, you already sent me the transcript, which I've just sort of held off until we've done the meeting.
Yeah, okay. So Peter can just send it out to everybody. And the link, obviously. Yeah. So, yeah, okay, he goes into a question and answer session now, which I think is also worth watching. So perhaps just watch that on your own. But I think this is actually rather fascinating because, if we believe everything he says, he seems to have an explanation for dark matter. He talks about a lot of stuff I've never heard of before. So it's really going to take some digesting. But I think this is fantastic. Now, what do you think? Peter, what's your opinion?
One thing I'd like to ask. We've heard of singularities, and they've been disputed. Some people say no, there's no such thing, etc., etc. But assuming there is, I wouldn't have thought that could be more than one type of singularity. That he mentions a special type of singularity.
Yeah, so I don't know. He talks about conformal, but if you've read some of Penrose's stuff, I did read a book where he wrote explaining the conformal sort of universe and how that whole theory of his, where it's sort of repeating in cycles, cyclical. Sort of. I understood it while I was reading it. But I wouldn't be able to explain it to you right now, but I do remember understanding it when I read it. So yeah, I think the way I see it is the singularity. Singularity is supposed to be infinitely small and have no dimension. I just can't conceive of anything like that. I just believe it was pretty small, but not a total dimensionless singularity. Except something which is dimensionless that has no scale. So it doesn't matter, you don't have to think of everything being in such a small space that it's impossibly small to measure. It's actually impossibly small and impossibly large simultaneously. So I don't know if that helps, but yeah. Okay, anybody else got comments or suggestions as to how to interpret this lot?
Also, if you look at him, he's using a couple of constants, and one of them is -1 squared, because he's talking about the dual. I'm trying to explain what I'm thinking is the dual aspect of direction. Because if all part of it that has a vector or a scalar, whichever you're looking at, scalar's directionless. So how can he make a continuous formula when he's using those factors? That's what I get stuck with my maths.
Yeah, look, I mean, how that formula is made up and how that's obviously probably take you 10 years of studying to understand it. So unfortunately,
yeah, not
beyond the scope of this evening session. So
yeah,
we have to accept that he knows what he's talking about.
Yeah, go along with that. Go along with that.
Yeah. but it's just interesting to me that he's very convinced that he's worked out what dark matter is. Dark matter is just a right-handed neutrino popping in and out of existence, which he seems convinced that that's what it is. And he seems to have, in his mind, he seems to have more or less sorted out everything that the universe is about and how it came into and goes into and out of existence. So yeah. I've never heard anybody being so confident about explaining everything as he is. So it'd be interesting to see what the critics say about everything he said.
Yeah, I think one point that impressed me was he used the word "we have solved the equation." So obviously it's a huge collaboration. I mean, working in conjunction with all the physicists involved in CERN, for example, there's a huge number of physicists who've actually, when he says "we," I think he means the whole
team.
The whole team, if you like.
Absolutely,
so I think
it's more than just a team. I think it's a whole lot of physicists all around the world working on probably certain aspects of everything, and cobbling it all together to make sense, so that there's nothing contradicting something somewhere else.
And he must have they must have a fair degree of confidence in actually putting forward this theory. So it's obviously, I think, quite important that they seem to be getting there. And he said at the end that they've got some designs in progress which might take 30 to 40 years, and I wasn't quite sure what he was meaning there. To be able to measure down to that quantum.
It's just the engineering of measuring the gravitational wave to that degree of accuracy where they can do that. So it's engineering. I mean, it's mind-boggling engineering. I mean, the thing they've got is already, the thing is kilometers long, but it measures to an accuracy of fractions of an atom, sort of thing. So this is to get it 1,000 times more accurate than that. So this it's the engineering to do it right now doesn't exist, but he says they are working on prototypes of what they would need to do to get it. So interesting. Maybe there will be breakthroughs which will speed it up at some stage, which often happens. So if they get to that, then they'll be able to see using a gravitational wave telescope right back to the Big Bang. I think it's all very fascinating. I did watch the bit about the questions a while back, but I haven't. I can't remember what it's all about. This is the sort of thing I think one's going to have to watch this thing over and over again, and I think it's all going to become sort of common knowledge soon. That's my impression that I get. Everything, it's going to be the common sort of new theories, new directions of solving what the universe is about. So it definitely seems, the MOND people want to say you only need MOND, but you don't need dark matter. But this seems to say, this is how dark matter could exist. I have seen there was a video. I saw the title of it recently. Final proof that MOND does not exist or does not work, and I think it was presented by Sabine Hossenfelder, so maybe we can look at that one sometime. I'll have a look and see if it's worth looking at, but I'm pretty sure it is. So I think things are moving along rapidly as far as physics is concerned. All very interesting. Is everybody in a hurry to go and not make comments, or anybody else got comments?
Well, I can comment. I was just thinking there's an answer here. This theory and his answer and the way he's explained it, and I don't say invented the particles, he just added them in to solve the problem. And at the end of the day, does it make any difference to the standard model and the way we apply it?
So everything he talks about, he's tried to make it fit into what can be observed and is. This is what I like about his approach. you know, where a lot of these theories, they invent things which we can never prove whether they exist or not. Everything he said
Right.
can be, and he said they are working on observing and proving everything that they are saying. So he's not talking about airy fairy stuff here. It's all, some of it is going to take decades and it's going to be difficult to prove, but it's not something which can never be proved.
This, of course, is the basis of all science, isn't it?
Yeah. So I'm 90% convinced with everything he says. I mean, I think he spent his lifetime sort of working all these angles. And he's South African.
Is he South African, really?
Yes. Yes, his father was an ANC MP.
Huh, I did not know that. Derek, right in the beginning of his talk, he invited the audience to criticize his presentation and to disprove it if they could. It would be interesting to listen to the questions and answers. There must have been some searching questions.
If anybody wants to carry on and listen to that now, I'm happy to do that. Otherwise, you can do that in your own time. I'm happy to put it back on. People that need to go must go, but if enough people want to stay and listen, who votes that we carry on with it? It's only another about 20 minutes.
Yep, go for it.
Right, I'm going to. Right, I'm going to stop recording and put that on again, and if people have to go, then
I have to say good night.
Okay, I'm going to carry on with the rest then.
Yeah. Fun, Derek.
Yeah.
That's enlightenment. Yes, absolutely.
All right. So just for a matter of interest, I just checked on Wikipedia. Turok it says that Turok was born in Johannesburg. In fact, 2 days before my wife was born. He was born on the 16th of November, 1958 in Johannesburg. So he's a South African boy. Yeah. Okay. Anybody know what CPT is? Anybody want to know? I've just been looking it up, but the more I look at, the more complex it is. Something about charge parity and direction of time, and it's all the CPT theorem is all about symmetry, I think. But exactly what it's about, I'm not quite sure. He keeps on mentioning it, but it's obviously quite a complex thing.
Thank you for the extra time, Derek. But he answered those questions very well, all of them, didn't he?
He's really very sure of himself, I think. You know, it seems quite a nebulous sort of thing that he's delving into. But he obviously knows an enormous amount about it. That's just not enough time to talk about. So I think we should follow him with interest, you know, whenever we get new stuff from him. So we're probably going to get a book from him explaining what I mean, actually, what's that question the last guy asked? Why does the universe exist? What did he ask? Maybe that's the one thing he won't be able to explain, but it sounds like he'll be able to explain everything else.
He can't possibly ask what's it all about without saying what's the purpose, and you know, that I don't believe is a proper question.
Well, first you've got to believe that there is a purpose before you ask what's the purpose. Maybe there isn't a purpose.
Yeah, I keep repeating what Fred Hoyle said. There's 200,000 proteins that are relevant to life in this, and the chances of them coming together as a pure random it's 10 to the power of 21, 10 to the power of 214 to 1 against. In other words, it's such a large number, and the chances of them all coming together at the right time can easily be the answer and why we are probably the only people in the living universe that we can see. You look at how many
Yeah,
possibilities.
I think there is some, not everything is by chance. There are relationships which dictate how things happen, which has some say in how things evolve. So yeah, that's a whole another topic, which we can talk about another time. Okay.
Yeah.
I'm going to say thank you very much to everyone for your attendance. I thought this was very interesting, and I think I will follow all his future work with great interest. I don't know about you.
Good
You
point.
agree, Albert?
Yeah, thank you very much.
Yeah.
Thank you. That was very entertaining.
All right, I thought so too. Okay.
Seeing somebody who's a master of their field explain complex things in a very easy manner to understand, easy to understand. It's wonderful experiencing that.
Well, easy to a degree, yes. Easy. I don't know how much of his formulas you understood, but you didn't have to understand the formula to understand what he was saying. I think we understood the gist of what he was saying. Is what you are implying now.
I will want to look up Sidney Poitier's view of the universe.
Yes, that piqued my curiosity. I'd like to know what he said. Okay.
Being a non-science person. Okay, thank you.
Thanks very much for attending, everybody. I enjoyed that. We'll see you next time. Cheers. Bye.
Right.
Bye. Okay.